Okay, so thank you for coming to this session about Groovy. Before we see anything on screen, just let me know who you are. How many of you are already Groovy users today? Okay, so about half of the room. How many already implemented some DSLs using Groovy? Okay. How many of you do not know what is a DSL? Right. So maybe you should come to the front. Right. So this session is about building DSLs using Groovy today. And I am working from Gradle. This slideware is written using Gradle and ASCII Doctor. And actually the title is not that nice because in Groovy we can remove all the semicolons and the parents. So let's change that in my slides right now. Okay, it's saved. And hopefully it's going to be updated. Yes. So now we're ready to start. Much better. So who I am? So my name is Cédric Champeau. I'm French. I said already I'm working for Gradle. If you have questions about Gradle, if you're not yet a Gradle user and know why you should migrate to Gradle, come to talk to me after the talk. I implemented some features of Groovy recently. Some features like the static compiler, traits, something that we will see, which is a markup template engine. And I started working with Groovy a few years ago. And my main focus was actually about DSLs in Groovy. So I chose Groovy for a very particular reason, and I continued to work on that topic, improving Groovy itself, and then I eventually became a committer. And now I am working on Groovy as what we call a committer at the Apache Software Foundation. So Groovy is not dead, despite what you could hear here and there. Groovy is very well alive. You can submit pull requests. We're very happy to do it and to merge everything. So the topic today is more DSLs. So just for you in the back, what is a DSL? Is a language that could be either developed by yourself or external, which is aimed towards a specific domain. So we have the typical example that we use generally is SQL, which is a language dedicated at performing database queries. So there are some key concepts in DSLs. There are many concepts. You find many books about DSLs, how you should design DSLs, etc. But the concepts that we can find here, like focused, which means a single domain, readable, which means that the target of the DSL is not a machine, it's really a user, a human, so usually you want to read the code. Of course, practical to use, and this one is especially particular for Groovy. It means that you want to embed the DSL into an existing application or enhance an existing application with DSL capabilities. So we're going to talk about that. If you have questions during the talk, maybe, given the room, it's going to be a bit difficult to interrupt the talk. But if you have a question, maybe you can just try to send me a tweet on the GroovyLang DSL hashtags, and maybe in the end I could read it and answer your questions. Feel free to do it. Okay, so why you would choose actually Groovy to write a DSL, to implement a DSL? And there are some very particular features of the language that make it possible to do it. First of all, and main, is really that the syntax of Groovy itself is very lean. It is very clear, and it's so easy to make it readable. So the syntax of the language makes it possible to create languages, DSLs, which are very practical to use as a human. And this is a key concept. The second one, is scripting, because, as I said, you probably want to embed some scripting features into your application and have maybe, say, a language dedicated to some features of your application. Not all the features, but some particular features, some domain in your application. And that requires to execute the DSLs at what we call runtime. So when I said that I started using Groovy using DSLs, it is actually true. And I started doing Groovy DSLs in a context which is very different from what I do today. I was using Groovy to implement some natural language processing engine. And the language that we used was a DSL designed in Groovy, and that DSL was targeted at linguists, not developers. And it was interesting to have Groovy to do it because the tool that we had at hand was the same for the linguists and for the developers. And we will see that there are other advantages of doing that. Next point about Groovy, using Groovy, is that it supports metaprogramming. So metaprogramming can be seen sometimes as something magic, but magic exists in DSL. I mean, we live in a world full of magic. Everybody knows about that. The problem often is that users don't understand the magic, because there's not magic, in fact. It's metaprogramming. And what you will have to do is to try to make your DSL not look so magic at all. And metaprogramming techniques in Groovy, you have two kinds of metaprogramming techniques. The usual one, which is the easiest, is runtime metaprogramming, which means that you will change the behavior of the program basically at runtime. And you have the other side of things, which is compile time metaprogramming. So you take a script, you modify it during the compilation of the script, and then at runtime, nothing happens in particular. So Groovy provides the two aspects, and each of them have some advantages and some disadvantages. Last point is really obvious. Groovy is a language which is supported by all the main IDEs that you have today. So Eclipse, IntelliJ, NetBeans, VI, not Emacs. Oh yes, are some Emacs users maybe? No. Okay, so it was also important for me when I chose Groovy actually, because those linguists were using the same language, but also the same tools, and they had actually support from the IDE. So when they wrote the rules, they were using IntelliJ in that case. It was very practical. So, let's start. The topic was building DSLs in Groovy today, because Groovy is more than 10 years old now, and it has dramatically changed since version 1, and you have many, many options to do the same thing. But also it means that today the way you would write a DSL is very different from the way you would have done it 10 years ago. So the little, yeah, maybe I can just skip that. Maybe the little disclaimer that I should say is that when I say that some language is old, it doesn't mean that it doesn't work. It doesn't mean that it doesn't do what it should do. It means that, in my opinion, it shouldn't be done that way today. And it's very different from saying it sucks, right? If it does the job, okay, you have no reason to change it. But today, if you want to implement something, maybe there are some ideas that you can do. So, just some examples of what I call old-looking DSLs. The first one is actually interesting, and I'm an IntelliJ user. I'm a happy user, very happy user, and actually one of the key features of IntelliJ is that you can have a DSL that describes DSLs. And this is made to support completion. And what it does is that you write a script which enhances the comprehension that the IDE has about your DSL at editing time. So you can provide some hints to the IDE for completion, for the types, etc. So it's a DSL that exists today in IntelliJ, and it's actually interesting to know that you have that tool at hand if you want to provide user support. But when you look actually at that DSL, it looks pretty much like code. It is code, actually, very much like code. So you have some words, verbs, you have some actions, but really it's not very user-friendly. And more importantly, it relies on that syntax. So I think that most of you said they were familiar with Groovy. If you're not familiar with Groovy, this is a map. And what is the problem with maps? What are the keys available? You know. You have no idea what you should put here, there, and there when you want to have completion, typically. So the user will have to read the documentation. And are you happy with reading the documentation when you use a framework? Usually no. It's last resort, because the documentation sucks. A second example, how many of you are Grails users? Okay, so I need to explain that one. So the first version of Grails, which is a web framework written in Groovy, have an abstraction layer on top of SQL queries to simplify everything. So you have some entities. In that case, I have a person entity. And that method that we have there looks like a static method. But if you take a look at the code of the person class, there's no such method. It doesn't exist. It's not defined on the person class. It is totally dynamic. So it means that when Groovy sees that method at runtime, and it's important to understand that it is at runtime, when it sees that method, it finds that actually it starts with find, and then it will parse the method name to try to find what it means. In that case, it's pretty obvious, find by last name, so I'm trying to find something in the person catalog for the stock string. And that's a query, that's a SQL query, which is created in the hood. So, okay, that works, but it has some problems. The first one, of course, is that what if you write it wrong? What happens? Well, of course, you have unit tests, or maybe not. So it will fail in production on a Friday evening. Okay, so maybe we can do better. And the last one in that example is actually the findAll method. And that one comes from Groovy itself. And this always annoys me. I hate to have to write this, it. Why do I have to write it everywhere? I know that when I am iterating on a person list, I know that the object that I will manipulate inside the closure is a person. So why do you ask me to say it explicitly? I don't want to do it. I just want to say findAll alive, done. So Gradle also has some problems with DSLs. How many of you are happy with the IDE supporting Gradle? Well, those of you who use Gradle, come on, at least one hand, please. Thank you. So, can anyone tell me what is the difference between the two? snippets of code that I have there. If you know Gradle, of course. If you don't know Gradle, it's not a problem. Sorry? No. Yeah, I heard do last. So that's the answer. Do last. So Gradle has this specific syntax, which is the double arrow here. And what it means is that the code that you see here is executed when the task is executed. Whereas in the second case, what you have here is some code which is executed when the task is configured. So Gradle is a build tool which is made on the notion of a task graph. So there are two phases: configuration phase, where you configure all the tasks that must be executed, and then once you have the full task graph, you can execute the build. So if you forget that, what happens is that you execute some code when the tasks are supposed to be configured, not when they're executed. And I think for such a huge difference in behavior, 2 characters are not enough. So you should never do that. And I would probably, if I were to redo the DSL today, I would probably remove that and force people to use the do last block. And the do last block exactly means I want to do that when the task is executed. And it is explicit. So the idea behind that is really that if you have something which is important and has a semantic difference which is important, it should be visible in the DSL. And the goal of DSL design is not to be as short as possible. It's not that. It's to be readable and understandable. If it's short and readable, it's better. But be careful. Other thoughts about Groovy. If you remove the semicolons, you're not building a DSL. You're just writing regular Groovy code. And it's actually pretty funny because even if it seems very obvious, just try to search Google for Groovy DSL for my favorite library. And often what you will see is a Java library, and the code snippet is just Java code without the semicolons. No, it doesn't make a Groovy DSL. And the same, it's not because you remove the parentheses that you're creating a DSL. You're just having some syntactic sugar, nothing more. So when you will design your DSL, what is important to think is what it will bring to the user compared to a plain Java or plain your favorite language code. That is very different. The problem, as I said, is that in Groovy you have many options. And that is true for implementation, but it is also true when you will design the DSL. And especially, it's very easy to create many ways to do the same thing with a different syntax. For the users, often this is not very pleasant, because if you have 2 ways to do the same thing, one day the question will be, what is the difference between the 2? And if your answer is, there is no difference, you start to have problems. That's my opinion. The last one is try to be idiomatic, so it's just, if you ever saw the talk that Guillaume gave about being idiomatic in Groovy, Groovy with style. If you did not, go on a website, you have a full section of Groovy that is specifically aimed towards how you should write your Groovy code today if it was its language without any knowledge of Java. Okay. So the next steps is really what we want to do today. What is a new Groovy DSL? How many of you use Spock? Good. So this side, that's funny. Why don't you? You should. You must. I mean, It's a pain to write JUnit tests. Or maybe you don't write tests, okay. So it's a pain to write unit tests, but with Spock it's so easy and it's so readable. So if you don't know Spock, it's okay. If you don't know Spock, just read that. Given, when, then. It's behavior-driven testing. So given something, when something happens, I want to check that something. It's very readable. And actually what Spock will let you do is also to attach labels to the labels. It's a label. So you can put a string there. You could put a string there, you can put a string there, and what will happen is that the test report that you will have those strings inside. And it is very interesting because it means that when you produce the report, actually your manager can read it. And it's readable in a human form. But it's not the most important aspect here. What is interesting is Spock is probably the oldest modern Groovy DSL because it's the first framework that heavily relies on hasty transformations. If you don't know what an hasty transformation is, don't be afraid. It doesn't bite. It's code generation, to be clear, macros. Maybe VB users there? No. So it's a macro. And what you do there, if you try to execute that code into regular Groovy source code, it wouldn't behave like if you do exactly the same within Spock. And that is because Spock transforms this code into something that can be executed as a test. So it is a technique that you can use. So in just an hour, I won't have any time to explain to you how you can do that, how you can manipulate the code. But the idea is more to give you pointers, to give you ideas of what you can do. Oh, we're back to Grails. So I said that Grails had a problem with the dynamic finders. And actually they solved that. They solved that problem in Grails 3. And in Grails 3 you have the new syntax, which is person.findAll. You have all the words you can use find, you can use, well, you know much better than me. You can do queries. And the syntax that you have there is very interesting for multiple reasons. First of all, can you tell me what is the packing storage engine in there? No, you can't. So it totally abstracts the fact that I could use MongoDB, for example, there. I don't care, actually. What I care as a user is to say, I want to perform a query. I don't care about the packing engine. I want to perform a query, and the query is that last name is Stark, and that guy should be still alive. Probably is going to be empty. So what is the difference with the previous example in Grails? The first example that I showed, it was a method, and the method name was dynamic. Here, what I have is a method which is defined, and this here is actually transformed at compile time, not at runtime. So if you make a mistake in your query, you will have an error at compile time when you compile that query, compile your source code. So you have much more feedback and actually much earlier in the development phase. So that doesn't prevent you from writing your tests, but at least you have some feedback. Because even if the dynamic finders were very practical, really in practice they were very limited, and you had the feedback much later. Gradle also has a new kind of DSL. So if you look at that code, this is how in the future you're going to use Gradle to describe what is your software. If you use Maven today, you don't describe software. You describe plugins that you use, you describe eventually, you can describe maybe how you have additional source sets, maybe, but you don't really describe what is your software and how it is composed. In this example, what we have is that we'd say, hey, Gradle, here's my software model. In my model, I have some components in my application. One of them is a JVM library, which is called main. And actually, to compile the Java sources, I have a dependency on something which is mylib. Interestingly, I'm saying, okay, this main library is only meant to target Java 8. Where is mylib? Well, actually mylib is another component of my software. It's also a JVM library. This time, this component targets two different platforms, Java 5 and Java 6. What I could do is also describe what specific dependencies I need for Java 6 or Java 5. For example, if I use features of Java 6 in Java 5, it would be a problem. But if I have a backport library, maybe I can use there. So maybe I could describe the dependencies specifically for that variant. That's nice. But also, I have that API block. And if you saw, maybe some of you were at the Jigsaw talks this week, that's exactly the same concept. You describe what packages are in your library. And actually, the packages that are supposed to be exported to consumers. So, if I have in my mylib library a package which is internal, it is not visible to the consumers. So it means that if my main library tries to access a class which is not in the exported packages, it's going to be a compile time error. So you have today, with Java 6, Java 7, Java 8, you have today the same behavior as what you would have tomorrow with Jigsaw. And you have it today with Gradle. And more importantly, the day you choose to use Java 9, we will generate the module info file for you. So you can get prepared today. And the idea is that this DSL is specified exactly for one aspect, describing your software model. Ratpack. Maybe some of you were at the Ratpack talk. It's a web framework, and it is very interesting because it's very modern in its design. It's using Java 8 minimally. It's totally asynchronous. But the DSL that we have for Groovy is also interesting because it's very clear. You have a Ratpack top level, and then you have some handlers with getters. You can describe everything you want. It is readable. I mean, I can understand that actually this is something that will render when I do a get. It is understandable just reading it. And what is important with Ratpack is that this can be statically compiled, so you can have errors at compile time too. Very nice. How many Jenkins users? Yeah. So maybe you're already using the Jenkins job DSL. It is also some kind of modern DSL because it's very readable. It's using the builder syntax. It is very simple to understand what it does. There's only one problem on that slide. Can you spot it? Yes, it's using Maven. Okay, so one more example, the markup template engine. And this one was designed partly because I was fed up with the existing template engine because I am not an HTML developer and I hate to forget to close a div tag. It is so annoying. I mean, if you just read some HTML and you have all those blocks and you forgot one div there, you're doomed. It is terrible. So what I wanted to do for the new Groovy website is having a template engine that would do that job for me. So we have a syntax, which is a builder. It doesn't look very special, actually. But what it does is very complex. This whole code can be statically compiled. It doesn't know anything about the HTML method. It doesn't know anything about body method. I could use my own tags. Still, it would be statically compiled. It had some features that will let you import other templates, combine templates, have some composition features. You can check out the docs if you're interested in that. But what is nice is that what I'm doing here is just one way to declare what are the types of the objects I put into the binding of my template before it is rendered. So doing that, I am declaring that I have a person's variable into my template, which is available to my template, and its type is a list of strings, right? And I said, when the template is going to be compiled, it is statically compiled. So what will happen when we reach the persons here? Persons is exactly something which is into the binding, so the template engine knows that it is into the binding. So it knows that P here is a string. And when it would try to create a list item with p.name, what is going to happen? Compile time error. So the second advantage is that when you compile the template, not when it's rendered, when you compile it, you have a compile time error. So you can catch the errors in your templates much sooner too. And that's really another example of what I think modern DSLs should care about. It's having early feedback. You certainly don't want to have something failing in production. So if you have the tools to do it, why not? If you don't have the tools, of course, you have no choice, rely on runtime and fail on runtime. But if you have the tools, you can try it. And the second aspect is that this is not born from day one. You can incrementally improve your DSL and incrementally add some checking at compile time. It is totally doable to do that, and that's exactly how it was designed. In the first place, it wasn't type checked. The idea was more to have something statically compilable, but not type checked. And you can do it. You can do that. So we have tools for that. I'm going to talk about that. So back to the basics. Closures are everywhere in Groovy. So for those of you who are not familiar with closures, it is exactly that. The block that you see there is a closure. So it's an HTML method, and it has exactly one argument, which is a closure. And the closure in Groovy is not like a lambda in Java 8. A closure in Groovy is really an object. It's a first-class citizen. So it's not translated into a functional interface. It's really something which is of a class closure. So you can manipulate it. It's actually interesting to manipulate it. So closures have new annotations that were added specifically to improve IDE support and to improve type checking. So we'll see. The second tool that we're going to use is compilation customizers. Anybody knows what they are? Okay. AST transformations, so the macro stuff. Some people use it already. Okay. Typechecking extensions, I'm going to talk about that. And the last one is very easy. You can use the Groovy shell. And Groovy shell is actually my favorite tool to debug Groovy code. Just write some code, you can have access to the AST, the abstract syntax tree. It's so easy, so use it. Closures. So let's fix the first bug. Well, no, it's not a bug. It's something that should not have been done that way in Groovy. The collect method that takes it, and it's ugly. I don't want it anymore. So let's fix it. Okay. This looks weird. I have to write so much code to do that? No, really not. Actually, there's more in that. Just focus on that. This is the implementation of a new collect method that I called myCollect. And what it does is just setting the strategy of the closure resolution. And the strategy is where at runtime we will look at when we call a method or a property. So when we do length, it's implicit. There's no this here. It's delegate dot something. So it's delegate dot something because I'm saying delegate first. It's a simplification. You have all the documentation to understand what the different strategies for delegation are in Groovy. It's pretty easy to set the delegate. You can even generate code to do that. What is interesting is that now I have a super method which is help extension.myCollect, because I like myCollect, that takes a string list, and yeah, I don't have it anymore. Victory. And it's a super DSL. No? Well, it's not that super just because I have to write all this. That's a bit annoying. Well, yes and no, because I can fix it. I'm just going to add a descriptor file that I will find on ClassPath, and I'm saying that it's an extension module, actually, that I'm writing. And this is why I use the wrapper class called helper extension. And doing that, I'll come back later. Okay, so it's a static method, and actually the first argument that I have is the list, and what I'm doing is decorating list with a new method. So I'm decorating list with a new method which is called myCollect. And as soon as I write this descriptor, this method becomes directly available to the list in Groovy. So it means that now I can call myCollect that way. And it's much nicer. So Groovy lets you do exactly what it does to JDK classes. When you see the URL.getText method, if you take a look at the JDK, there's no getText method on URL class. Yet in Groovy you can call myURL.getText, and it's exactly implemented that way. You create a static method with the type of the element you want to decorate as the first arguments, and then the arguments of your method. And doing that, you decorate existing elements. So it might really look arbitrary to do that, and it might not look like best practices in developments. But actually, in the context of DSLs, it's very practical, because this allows you to enhance existing DSLs. Imagine that you have that builder syntax, and that you want to add a new method to something which is inside, in an element of the closure hierarchy. You can do that with an extension method because you know the type of the delegate that you're decorating. So without having to change the source code of the initial DSL, you can update it and you can add new behaviors. So it's very useful. Declaring the delegate type is exactly what the delegates2 method is about. And this is done for two reasons. As I said, first one, IDE support. Second one, type checking. When we have that method, how the IDE knows that actually here you don't need it. It doesn't know. You know it as the DSL designer. But the IDE doesn't know, and it doesn't know because this is code that has to be executed to understand what is the delegate type. But you as the DSL designer, you know it. So please help the type checker, please help the IDE and tell it, okay, in the context of my closure, The type of the delegate is going to be first param dot first generic type. What does it mean? The first parameter of my method is the list of t, so the first generic type is a t. So if I use that method on list of strings, I know that the delegate is going to be a string. If it's a list of integers, I know that the delegate is going to be an integer. Problem solved. So there are many options that you can use in delegates to tell actually the ID what is the type of the delegate. The first version is very obvious. Just give it the type, and you can go very far into what you specify. Is that okay so far? So removing ceremony, and this is something special for Venkat, because he always likes ceremony code. So when I say, is your DSL self-contained? What I mean is that if your DSL is supposed to be executed into an isolated context, such as a script, a rule script in a rule engine, a Gradle build, so a Gradle script, it has some context. It has some knowledge about the execution context. So what you should try to do is remove everything that the user shouldn't have to write. So typically, I consider that a user of a DSL should never have to write an import. Imports is for developers. You want to know that you import class X. A user doesn't care about imports. And in case of the linguist that I had as a user, they didn't even know what was an import. What was a class? Doesn't make any sense for them. So if you try to tell them, okay, you have to write import something for your script to work, they say, what? Why do I have to do that? If you ask them to write new, foo equals new foo, doesn't make any sense. What does it mean, new? And actually, I vote for the removal of the new keyword in Groovy. If you want to remove, it doesn't make any sense to have a new keyword. I mean, it's pure arbitrary syntax. And the last one is avoid usage of annotations, just because annotation hell. So if you took a look at the Spring Boot application today, you have more annotations than you have code. Yeah, before it was more XML. So one plague for another. What is a sum type? Sum type. Single abstract method type. So it's very easy, in fact. It's a type, a class, and that class has a single method which is not implemented. So you can have it in an interface or you can have it on an abstract class. And this is the case here with the handler class, and you have to implement the handle method because this is the only one that you have to implement. And this is super ugly. Please do not do that for your users. Don't force them to write new handler, overwrite, void, handle. They don't care. What they want to write is serve, print, message. Done. No ceremony code. And the good news is that you have that for free in Groovy. As soon as you have a sum type as a method parameter, you can use a closure there. Some of you could say it's pretty similar to what you can do with lambdas in Java, but lambdas are limited to interfaces, whereas in Groovy you can use abstract classes. It doesn't mean that we're better than Java, not at all. It's just that you have more information and more context, you can do that. So, yeah, use sum types and use the features that the language provides to you. Compilation customizers are exactly about removing that ceremony code. So here, my script for the user was serve. And if you try to compile that, what will happen? It will compile, okay? But actually, you don't know where the serve method is defined. If I have the code here, I know that actually serve is a static method on the web server class. And it has delegates too with a server spec. So actually what happens inside is a specification of what I want to serve. That's nice. But how can I avoid writing web server dot? This is ceremony code. I want to remove that. How do I do that? Compilation customizers. And what it means is that you will configure the context of the script. And in that case, I want to do a star import of web server. So I want all the methods of web server which are static to be available directly in my script. So I'm configuring the script with the add static stars on the web server class. So it means that when Groovy will compile that script, web server serve is going to be found on the web server class. And I don't have to use import com acme web server dot star. You don't need it, remove it, and your users will be happy. So you have multiple compilation customizers. The import one is just what I showed. AST transformation customizer is interesting because it will let you apply transformations transparently. So when I talk about static compilation, it is actually implemented as an AST transformation in Groovy itself. So if you want to compile statically your scripts, you can do that using AST transformation customizer. And then you don't have to put an explicit compile static everywhere. That's interesting. The secure one is probably the most badly named thing ever in the Groovy codebase, and I chose the name, so blame me for that. And the idea for me was that the secure adjective that you can see here applies to the AST. It doesn't apply to any kind of secure context in the context of security policies of Java. No, it's not. It's about restricting the grammar of the language. And it can be interesting for some DSLs. Imagine that the DSL you want to implement is just an arithmetic calculator. You can do with this secure AST customizer, you can say, okay, in that context, in that script, it is not allowed to create a class. It is not allowed to call a method. It is not allowed to use a closure. And then what the user can do is very basic, 1 + 1, done. And if it tries something else, then it fails at compile time. The source away customizer is something that lets you do that kind of manipulations, though adding customizers, the AST secure customizer, you can do it on a per source file basis. So it lets you implement conventions. Imagine that you have a folder which has controllers and a folder that has views. You can apply different transformation based on what folder you have. This can be interesting for framework designers. Okay, so we have about 10 minutes left. Let's talk about type-checking extensions. The goal of type-checking extensions is really to give early feedback to the user. And early feedback is really what I want to enhance. My goal as a DSL designer is not type safety. Type safety is a bonus, but it's not a goal for me. Type safety is cool for user, for the IDE, it's cool for the developer, it's cool for you. You want type safety, probably because types, they give you that cage. You cannot extend, you can call something which is not in the type. So it's really cool for you as a developer, but the user doesn't care about types, doesn't want to know about types. He cares about the domain. He cares about the model. Types don't care. But type-checking extensions are a very cool way to provide that knowledge to the type checker and help the compiler understand the DSL. So how does it work? When I showed you the example of the markup template engine, it heavily relies on that. The idea is that when you apply type checking or static compilation to a script, because the compiler has no knowledge of all the imports that you added, of all the the model that you use, it doesn't even know about that HTML method that you want to call. It doesn't know anything. So what will happen if you try to compile that statically? Errors everywhere, cannot find method, variable is not defined, etc., etc., etc. And the idea behind typechecking extensions is that you can capture all those events and react to them. So the type checker will say, okay, here there's something I don't know about. It's an undefined variable. Can you tell me what is the type of this? Because when you will implement that, I know that you will provide it to me. I don't care how you provide it to me. I just want to know the type because this is what I care as a type checker. So you can tell the type checker, okay, if I find persons in my script, actually it's a list of strings. I don't find a method. Okay, this was the type of the receiver, this was the name of the method, you have some arguments. Since I do some type inference, I can provide you with the types, the info types of all the arguments, and maybe with all that information you can tell me actually what is the return type, what is the inferred return type of your method. So you can totally extend the behavior of the type checker, and it will understand everything that you as a designer of your DSL you know about. You can explain to it everything that it will find into the binding. So there are two aspects with that. The first one is that Groovy makes a clear separation between type checking and static compilation. And it was important to have that difference, because if you want to implement that, the first thing that you want to do is user feedback. You don't want static compilation at first. It's a bonus to be faster. It's a bonus to be statically compiled. But what you want to have is actually provide more errors to the user. And what you can do with that API is providing more users than the compiler can provide. So imagine that you have a string and you recognize that it is a SQL query. If it's Java code, it will see a string, it doesn't know anything about it. If you're using Groovy, you can recognize that this string is used in the context of a SQL query. You can parse it, and if it has a parse error, you can fail at compile time. So you can do much more than what a static compiler can typically do. The second aspect is that when you compile those scripts, you first apply type checking, because the compiler will not know how it is supposed to compile the persons that we had in the template, the call to persons. How is it supposed to know that it has to find it into the binding? It could very well be into a base template class, so a field in a class and not something in a map. So it doesn't know how to get that. So it was important to separate the two aspects, having a type checker and having static compilation, because the first step, which is easy to do, is providing the types to the type checker. And what is hard to do is to transform the script into something which is statically compilable. And that last step is what makes the markup template engine faster, basically, because it is not dynamic code, it is statically compiled code. But it's harder to do. So yeah, you will have the slides on my account, and you can take a look at the documentation for it, and we're very happy to have some feedback on the features. Okay, so 5 minutes left. Maybe I will just hand it over to the conclusion. So what we learned? We learned that using the syntax of Groovy, you can do many things. You can even totally transform the input into something that doesn't mean what it looks like. We learned that actually using those modern DSLs, you had a common pattern, which was the builder pattern. And the builder pattern without the ugly it. And scoping is very important, because at least I, as a human, I like to have something which is readable as a block. keeps you focused. You know that within that context, you have everything at hand. So you have to use the delegate. And if you start using the delegate, you can help the IDE and you can help the type checker. So to do that, you have to use delegates too. And one other annotation that I didn't have time to talk about, which is closure params, and is aimed towards helping the type checker what is the type of the parameters of the closures. Because in all the examples I gave here, there wasn't any parameter, but you can have parameters to closures. And you can explain to the type checker what are the types. Last, this one. I consider, at least, this is one of my objectives in Gradle. You should rely on imperative code as a last resort. So everything that can be described as a specification should be described as a specification. And last, if you have to write some imperative code somewhere to describe some specific thing that you have to do, you can do it. But it should be the last thing to do. Because code is not what users want to do. They want to define their model. Time for questions. Nobody. That's not surprising. Yeah.
Helper extension got rid of it. But why isn't that the default?
So is remove it a default behavior of Groovy?
Why do we need the helper extension? Why wasn't it?
Oh, to remove it, you don't need it. Just delegates to is enough. Because to remove it, the notion of delegate is bundled into the language. You have to use typechecking extensions as soon as the compiler doesn't know about something. So maybe in the delegate, actually, you can have a method in the closure which doesn't exist, and the type checker would say, hey, I didn't find it on the delegate, I didn't find it on the owner, I didn't find it in the scope, so please help me. So this is where you would use a type checking extension. As said, I would take a look if I had some questions, because people are shy and usually they don't want to ask publicly. And I don't have any network, so no questions. Yeah. Okay, so if you have questions, come talk to me after the talk. Thank you.